From section 2.4, so we have 54 and 57, and in 54 and 57 you are asked to find the domain and range. Okay, and we did like a few problems yesterday. I hope you can do finding domain and range. Okay, in 61 you are given a graph. You are asked to find whether a graph is a function or not. You use a vertical line test. If it crosses more than once, then it is not a function. Okay, it has to cross exactly once. In 62 you are given a graph, and okay, 62 we will do this 62 in our next section. Okay, we have like pretty similar question. And in 63 and 64 you have to just describe whether given equation is a function or not, and you can do by plotting a graph. Okay, so and from section 2.5, as I said earlier, like yesterday, you are not required to do anything from this review portion. Go back to the lecture handout and do those first 3 examples for this section 2.5. Okay, so you do not need to practice anything from the review section. Make sure you practice those 3 examples for section 2.5. Now let's go to section 2.6. So in 2.6 we have 77, number 77. We are asked to find whether a given function is a even function, odd function, or is neither. Okay, so let's take, so we have a function f of x equals to negative x squared plus 5. So we have this function and we want to know whether this function is even or odd. Okay, and the very first step is we replace x of a function by negative x. So you replace x of this function by negative x. Okay, if you want to know whether your function is even function or odd function, this is the very first step. You are replacing x of a function by negative x. So we have f of negative x equals, so for every x you're gonna replace by negative x. Okay, equals, we have negative, for x we're gonna have negative x, we have square plus 5. So you replace x of your function by negative x, and this is, we have negative, and square of negative x is positive x squared, right, plus 5. Now here the result, so this is the result here after replacing x of a function, and this is same as our f of x, right? So we can write this as a f of x. And if your f of negative x is equals to f of x, your function is even or odd? F is, if we get the same function, it's an even function. Okay, if we get the same function after replacing x of a function by negative x, we get the even, we have the even function. And you will have similar question on your exam. Okay, you will be given a function and you will be asked whether a function is even or odd. Okay, now let's do 79, one more, and it's, so we have number 79, and the function given to us is f of x equals to negative 3x to the power 5 negative x. Now we replace x of a function, so every x is replaced by negative x. So for every x we write down negative x. We have f is as it is. For x we have negative x equals, we have negative 3 as it is. For x we have negative x and the exponent 5 as it is. We have negative as it is, and for x we have negative x. So you are replacing x of a function by negative x. So this is negative 3, and the fifth power of negative x is negative x to the power 5th, right? So if you multiply negative x 5 times, we get negative x to the power 5th, and negative times negative x, that is positive x. This is equals to negative 3 times negative x to the power 5, that is negative So this is positive 3x to the power 5 positive x. Now we compare with our original function, and if we compare, we have the same terms, okay, and the only difference is that we have the opposite sign for each term. So we have negative 3x to the power 5, we have positive here. We have negative x, we have positive here. It means if this is the case, we can factor out negative, okay. So if you have the same term and exactly opposite sign for each term, your function is odd, okay. And we can rewrite this as we can factor out negative, and if we factor out negative, the sign of each term changes. So positive 3x to the 5 is negative 3x to the power 5, positive x is negative x. And what is this? So this is our f of x, right? So this is our f of x. So here we have negative f of x. So if f of negative x is equals to negative of f of x, then our function f is odd function. So for even function, after replacing negative x, you get the exactly same. For the odd, you get the same term, and every term has exactly opposite sign. That's the condition for the odd function. Okay, and you will have one function, one similar question on your exam, okay. Let me know if you have any question here. Okay, so let's go to the next one. That's number 83, from 83 to 88. So it's on the basis of the graph. So here we have the graph here. So this is from 83. Okay, so the graph we have, okay, 4, this point is negative 4 3. So we have this point negative 2 negative 1. We have this point 2 1. We have this point as a 3. We have 4 1. So this point is 4 1. Okay, and this is 5 1. So we have this graph. So we have a straight line here, then a straight line joining this point. We have a parabola here, then a straight line here. Okay, this is the graph given to us. Okay, this parabola is touching at positive 3, okay. And the very first, number 83, we have to write an interval where the function is increasing. Okay, so can you tell me the interval where the function is increasing? Now, on the basis of this graph, what is this x value? Can you tell me what is this x value? What is this point? Negative 4, okay. And whenever we are writing the interval, we are using the x values, okay, not the y. Okay, on the basis of this point, what would be this point? This is negative 2, right? So this is positive 2, this is 3, this is 4, and this is 5. Okay, now we are looking an interval where the function is increasing. Now, what is the interval where the function is increasing? Negative 2 to positive 2. That's right. So this portion of a graph, see, so this portion of a graph is rising. It means the function is increasing. So the corresponding x values from negative 2 to positive 2 is the interval where the function is increasing. So for 83, from negative 2 to positive 2. Now, do we have any more? Okay, now, so we have this portion of a graph, and this portion of a graph is also rising. So if you see a graph rising, and that's the graph increasing. So the corresponding x values is from 3 to 4. So this is the another interval from positive 3 to 4. Okay, so this is the interval where the function is increasing. Okay, we don't have any more. Now for 84, we are answering on the basis of same graph. Find the interval where the function is decreasing. Okay, what is the very first interval where the function is decreasing? Negative 4 to negative 2, right? So this portion of a graph is falling down, and if it's falling down means the function is decreasing. Okay, and we have one more portion here, so we are writing the interval notation for these two part. Okay, so from -4 to -2, and make sure you are using x values. Okay, you are using the x values, not the y. Okay, and the next interval is from +2 to 3, 2 to 3. So this is the interval where the function is decreasing. Okay, in 85, now do we have a constant function here? Okay, now what is the interval where the function is constant? So constant means the function is not rising, it's not falling. So this horizontal line is the constant, and this is from 4 to 5. So from 4 to 5. So this is the interval where the function is constant. Okay, now here one more thing. So here, so we have the closed circle here and we have the closed circle at the end. Okay, it means we can't extend this graph on the right and on the left. Okay, sometime you might have the arrow here. So okay, it means you can extend your graph on the right and left. So make sure whether you have an arrow on or is completely end point. Okay, and on the basis of this you might have a different answer. Okay, does anyone have a question here? Yes.
The intervals, do they have to be in square brackets?
Now here you can just use the okay, now here you can use a brackets or parentheses for writing the intervals. Okay, it really doesn't matter. Okay, now so when we have a so here, now if you have a bracket, it means you are including this -2 and +2, right? But like if we just check the graph at -2, it's a point, right? There's like nothing. We can't just find whether a function is increasing or decreasing at a point. It has to be certain interval. Okay, but it's not wrong. So if you use a bracket or if you use a parenthesis, you get the credit. Okay, you can use a bracket or parenthesis when you write the interval. Okay, now number 87, we have to find the average rate of change of a function f in the interval 3, 4. Okay, so we have the interval 3, 4, and we need to find the average rate of change. Okay, so this is number 87. And how do we find average rate of change? So average rate of change. So average rate of change is given by f of x2 minus f of x1 divided by x2 minus x1. So we have the interval, we have to find the average rate of change in the interval 3, 4. Okay, in 3, 4. So this is the interval, and we want to find the average rate of change. Now what is 3, 4 interval? Now let's find out. So 3, 4 is this, right? So we want to know how the function is changing in this interval. Okay, so we want f of x2, we want f of x1, we want x2, and we want x1. Now here, so what is f of x2? F of x is y, right? So f of x2 is y2, f of x1 is y1. Do not get confused. Now we have 2 points here. So this point, so we are starting from this portion. Okay, so we are starting from this point. Okay, and we have this point, ending point. Now for this point, what is the coordinate? 3, 0, right? So we have 3, 0, and the end point is this one, and the coordinate is given as 4, 1. So we have 4, 1. Okay, so let's say this is our x1, and if it's x1 is a y1, or you can just write f of x1, that's a y coordinate. Let's say this is x2 and this is our f of x2. Now you substitute your x1, f of x1, x2, f of x2, and we get the average rate of change. So we have f of x2 is 1 minus f of x1 is 0 divided by x2 is 4 minus x1 is 3. and this is 1 over 1, which is 1. So 1 is the average rate of change. So when you are finding the average rate of change, you need a 2-point starting point and an end point of that graph, okay, in that interval. You call your first point is x1 f of x1, second point is x2 f of x2, and you substitute here. And if you are asked to find average rate of change, you are not required to memorize this. You will be given on your question paper. Okay, let me know if you have any question. Okay, now let's go to next number 88. So find the y-intercept. Now in this graph, what is the y-intercept? Oh, okay. Now I have my graph is not correct here. So on your book, your graph passes through the origin. Okay. So, okay. Let me see if I can. Okay. So on our book, so we have this y-axis. Okay. So this is our y-axis. Now, can you tell me what is the y-intercept for this graph? Y-intercept is the point where the graph crosses y-axis, right? And it crosses at 0. So you can simply write 0 or 0, 0, okay? So the y-intercept is 0, 0. This is the y-intercept. And if you are asked to write down the x-intercept, you are writing a point where a graph crosses the x-axis, okay? So we have how many points here? So we have 1 point, 2, 3 point, right? So those 3 would be the x-intercept. Okay. Next, we need to find average rate of change for 89 and 91. Okay. And in this case, we are given a function. Let me do 1 and the next I think you can do. So in 89, we are given f of x equals to negative 2x plus 4. And we want to find the average rate of change in the interval 2, 3. So this is the interval given to us, and we need to find average rate of change. So let's call this is our x1. Since this is the interval, so the next is also x coordinates. Okay, it's not x1, y1 here. And our average rate of change is given by f of x2 minus f of x1 divided by x2 minus x1. Now, what would be f of x2? How do we find f of x2? Our x2 is 3. How do we find f of x2? We substitute 3, 4 in the function, right? So we have negative 2 times 3, that is negative 6 plus 4, that is negative 2, minus, we want to find f of x1. Our x1 is 2, so you substitute 2 for every x. So we have negative 2 times 2, negative 4 plus 4, that is 0. Divided by x2 is 3 minus x1 is 2. So we have negative 2 divided by 1, and negative 2 is the average rate of change. Okay, if you are given a graph, you need to find the coordinates. Okay, if it's given a function, not a graph, then you have to find the output by substituting your input in the function. Okay. In section 2.6, we did difference cosine 2, right? Is that in a different section or section 2.6? Let me make sure. I don't want to miss that because you will have one difference cosine problem. Okay. So it's in 2.7. Okay. So it's on. Okay. Okay. This is all about for section 2.6. Okay. Now in 2.7, so we have. Okay. 2.7. In 2.7, basically we've had the algebra of the function. We added the function, right? So let me make a revision here. So in 2.7, so if we want to find f plus g function, how do we find f plus g function? We add function, right? So this is f function plus g function. If we want to find f minus g function, then this is f function minus g function. Okay. If you want to find f times g function, then this is f function times g function. You multiply the function. If you want to find f over g function, then this is f function divided by g function. Okay, so this should be the easiest one, because we will be given f function, you will be given g function, and you will be asked to find f plus g, f minus g, or fg function. Okay, let me do one. So let me do 93. So in 93, our f of x is 4x squared plus 1, g of x is x plus 1, and we need to find all of these 4. So what is f plus g function? So you are adding these two functions, so you're going to add this function, f function, and g function. So f plus g function is f function plus g function. You substitute your f of x, which is 4x squared plus 1. We have plus in the middle. And you substitute g of x as x plus 1. You need to simplify. It means you need to look for the like terms. So we have 4x squared, 1 plus 1, 2, and we have x as it is. So this is our final answer. You are adding the function, you get f plus g. And similarly for f minus c, you find the difference. Okay, and when you find the difference, you have to be careful. So let's find f minus g of 2. How do we find this? We have the difference, okay, and instead of x we have 2, so you're gonna substitute 2 for every x, and you're gonna find the difference of two function. So this is f of 2 minus g of 2. The only difference is that we have a specific input 2 instead of x. So what will be f of 2? How do we find f of 2? You substitute 2 for every x in a f function. So our f function is 4x squared plus 1. And if you substitute 2 for x, we have 4 times 2 squared, 4 times 4, 16 plus 1, 17, right? Minus, now let's find g of 2. And in order to find g of 2, you substitute 2 for every x in g function. And we have our g function is x plus 1. And you substitute 2, we get 2 plus 1, 3. So 17 minus 3, and this is 14. 14 is the final answer. Similarly, you can find the f times g and f over g. Okay, it's pretty similar. So I want you to practice these. Okay, next, let me go to the composite function. Does anyone have question here? And next, let me use the same function. You will be asked to find the composite function. Okay, so if you are asked to find f composite g of x, how do we find f composite g? So this is not multiplication. Okay, so whenever you have this open circle, that's the composite. You have a 2 function, and you see this open circle, this is the composite. And we have to use the definition. Okay, and the definition for this composite function is the only thing that you need to do is that you replace your composite sign by parenthesis. So you have f as it is. For composite, you have parenthesis g of x. So this is the definition. Okay, so do not flip the position of a function. Okay, if you flip, you're gonna get the different answer. So only replace your composite by parenthesis and make sure you have the same position of a function. Okay, now we need to solve here. So we know what is g of x, right? Our g of x is x plus 1. So let's substitute x plus 1 for g of x. So we have f as it is. For g of x, we have x plus 1. Okay. Now, in the next, we need to find f of x plus 1. Okay. And how do we find f of x plus 1? We substitute whatever we have inside this parenthesis for every x in our f function. So this is our f function. Okay. So we substitute whatever we have inside the parenthesis for every x. Okay, so we have 4x squared plus 1. So let me just write down my f of x is 4x squared plus 1. Now in order to find f of x plus 1, you replace every x of a f function by this x plus 1. Okay, so we have 4 times x. For this x, we're gonna write x plus 1, x plus 1. We have a square. We have a 2 terms. Make sure you have the parentheses. Then plus 1, 1. Okay, and when you find the output, there is no more function f here. Okay, there is no f here. Once you find the output, your function is gone. Okay, but here in the first step, we just make a substitution here. Okay, so for g of x, we have x plus 1, and every time when you are finding the output, you are not writing the function name again. Okay, now the remaining is simplifying. Let's simplify. So we have a square here, we have a 2 terms here, so this is same as 4 times x plus 1 times x plus 1. Okay, so square means we have a x plus 1 2 times plus 1. Now let's use FOIL because we have a binomial here. So you multiply first term x times x. We have a product here, so this is 4. Make sure you have the parentheses. X times x, we have x squared. We multiply outside terms x times 1, that is positive x. You multiply inside terms 1 times x, you get x, and you multiply last terms 1 times 1, we get positive 1 and plus 1. Okay, and the reason we are having parentheses here is that because we're gonna have more than 1 terms, and every time if you have a negative terms or if you have more than 1 terms, make sure you write those terms inside the parentheses. Okay, now we have a multiplication. We're gonna distribute 4 for each term. 4 times x squared, 4x squared, 4 times x, 4x, 4 times x, 4x, 4 times 1, 4 plus 1. We look for the like terms. So we have 4x squared, this is x squared, plus 4x, 8x, plus 4 plus 1, 5. Okay, so this is our composite function. And similarly, we can also find g composite f of x. Okay, and the definition is you're gonna have g at first, parenthesis f of x. So in this case, you substitute f of x at first, okay, which is 4x squared plus 1. So we have g as it is. Our f of x is 4x squared plus 1. Now we find g of this expression. So in order to find g of this expression, you substitute this 4x squared plus 1 for every x in your g function, and our g function is g function is x plus 1. Okay, so g function is x plus 1. So for every x, you're gonna substitute this expression. So we have x. So for x, we're gonna have 4x squared plus 1. We have plus, and we have 1. We have 1. So we simplify 4x squared plus 2 is the g composite f function. Okay, and the definition of composite, it won't be given for you. Okay, it's not difficult, so you won't have the definition. If you just replace your composite sign by the parenthesis, you get the definition. Do not switch the position of your function. Okay, all right, so remaining is finding the composite, so you can do the remaining. Okay, let me see what we have next here. Okay, finding domain, we did that. Okay, now let me go to the difference quotient. Okay, 119. Okay, do you have any question with a composite before we start the difference quotient? You will have the composite also, and you will have the difference quotient also. Okay, so we have a function f of x equals to 4x minus 3. And we are asked to find the difference quotient. It means we are asked to find f of x plus h minus f of x divided by h. So we are asked to find this expression. Now here, so this is what we are given to us, okay? So we have f of x and we need to find f of x plus h. That's the very first thing we need to find. And how do we find f of x plus h? So we are trying to find f of x plus h, right? So we are given f function. So what do? You substitute x plus h for every x in your f function, okay? So you have 4 as it is. So we have 4. So for this x, you're gonna substitute x plus h. We have a more than one term, so parenthesis x plus h. Then we have a negative, and 3. So parenthesis, okay? Whenever you have the negative terms or more than one terms, make sure you have the parenthesis for those terms. Okay, now we can go back and substitute these values. So for f of x plus h, we have 4 times x plus h minus 3. Then we have this negative, okay? So we have negative. And f of x, the f of x is, okay, so this is the f of x, and it is given as 4x minus 3. And make sure we have the negative here, so we need a parenthesis here, 4x minus 3 divided by h. Okay, now let's simplify this. So we distribute 4 times x, 4x, 4 times h, 4h, negative 3, minus, you distribute negative, and when you distribute negative, the sign changes. Negative times 4x, that is negative 4x, negative times negative 3, that is positive 3, divided by h. So we have 4x, negative 4x, 0, negative 3, positive 3, 0. So we have 4h divided by h. So we can cancel h and h because we have in a factor form, and our final answer is 4. So 4 is the final answer for this difference quotient. Good. You will have the difference quotient. You will be asked to find the difference quotient, and you don't need to know this expression. It will be given. Okay, you will be given this expression. You need to, the only thing that you need to find is f of x plus h, and the remaining is you substitute and simplify, and make sure to have your final answer in the simplest form. Okay, so this is all for section 2.7. okay, so chapter 2 is done. Now we have one more section, 4.1. And 4.1, the review for 4.1 is from its exercise. Okay, so for the review for section 4.1 is from the exercise. Do you have any question from chapter 2? Okay, now let's go section exercise 4.1. okay, this is okay. So we have number 12, and we are asked to verify the function are inverse of each other. Okay, so we have f of x equals to negative 8x and g of x equals to 1, okay, it's negative 1 over 8x. So we have these two functions, and it tells us to verify these two functions are inverse of each other. How do we verify? How do we know that the inverse of these two functions are inverse of each other? That's right. So we find the f composite g, we find the g composite f, and if we get both equals to x, then these two functions are inverse of each other. Okay, so let's find, so it's f composite g at first. So let's find f composite g of x. So this is f of g of x. So we have f as it is. So for g of x, we substitute negative 1 over 8x. Now we find f of negative 1 over 8x. And for that, we substitute negative 1 over 8x for every x in f function. So we have negative 8 times negative 1 over 8 times x. So we have a times here. So negative 8 times negative 1 over 8, that is positive 1 times x is x, right? Okay, so we have x. Now let's find g composite f of x. And this is g of f of x. So we have g as it is. For f of x, we have negative 8x. Now let's find g of negative 8x. You substitute negative 8x for every x in g function. So we have negative 1 over 8 times negative 8x. We have the product here. So negative 1 over 8 times negative 8, that is positive 1 times x is x. So here f composite g of x is equals to g composite of x, and this is equals to x. If this is the case, then our f and g are inverse of each other. So g is the inverse of f and f is the inverse of g. Okay, so this proves that function f and function g are inverse of each other. So you are finding the composite. Okay. Okay, the next you are asked to find whether a function is one-to-one or not in the table. So to be one-to-one, what do we want? So we want every input must have exactly one unique output, right? Then only we have a one-to-one function. Like for example, so let me give you an example and you can do the remaining. So we have this function h. Okay, so we have a, b, c, we have 1, 2, 3. So we have a corresponds with 1, b has output 2, and c has output 3. So here every input a, b, c, they have exactly one and unique output. Okay, so a has a output 1. Okay, this is, and b has output 2, c has output 3, and every input has unique output. It means this function is one-to-one. Okay, so h is one-to-one function. So if you are given a table, then if you find that every input has unique output, then your function is one-to-one. And if it's given a graph, how do we know whether a graph is one-to-one or not? We use a horizontal line test. Okay, and if a horizontal line crosses more than once, then it is not one-to-one. It has to cross exactly once. Okay, like for example, see if we have a graph like, okay, so is this a graph one-to-one? No, right? So if we draw a horizontal line, it crosses at 2 points. So this is not one-to-one. So whatever this one, it is one-to-one, right? See, exactly 1 point. Okay, so first graph, is this a function or not? So you draw a vertical line, it crosses exactly 1 point, right? So this is a function. And for the second graph, it crosses exactly 1 point, and this is a function. So you might need to use these two tests. Okay, you will be given a graph, you will be asked whether a graph is a function or not, whether a graph is one-to-one or not. Okay, for function, vertical line test; for one-to-one, horizontal line test. Okay. Okay, the next here from 29 to 34, you will have to check whether a function is one-to-one or not. Okay, so let me do number 30. So we have a function f of x equals to 4 over 3 x plus 1. And you need to check whether this function is one-to-one or not. You have to show, you have to verify. Okay, not a graphical method. You have to use algebra here. So for this, we consider any two inputs. Okay, so let's consider Consider inputs A, B, A and B, or you can just P, Q, anything, okay? And we assume the output for these inputs are same, okay? So we assume that our output f of A is equals to f of B. So you take any two input, it doesn't matter, okay? Any two variable as your input, okay? So we have our input A, B here. And let's also assume that the output for these two inputs are equal to each other. We don't know anything about the inputs. The inputs can be same, the inputs can be different, okay? At the beginning, we don't know whether they are same or they are different, but we have two different inputs, okay? But what we know, their outputs are same. Now let's find this f of A, f of B and simplify, and let's see what can we find about our inputs. How do we find f of A? What is f of A here? F of A is, you substitute A for every x, right? So we have 4 over 3A plus 1 equals to, in order to find f of B, you substitute B for every x in your f function. So we have 4 over 3B plus 1. So let's subtract 1 on both sides. We want to have these inputs by itself. So we have 4 over 3A equals 4 over 3B, because these cancel. Now how do we get rid of 3 from both sides? We multiply by 3 on both sides, right? So we multiply by 3. So these 3 cancel. So we have 4A equals to 4B. Now let's divide by 4 on both sides. We have A equals to B. And if you have A equals to B, this proves that a function is 1 to 1. Okay, so we started with a different input and a same output. Okay, so we started with a two different input having a same output. Okay, when we simplify, we found that those two inputs has to be same, and this proves that our function f is 1 to 1 function. F is 1 to 1 function. And if you get A not equals to B, then your function is not 1 to 1. Okay. Okay. So one more that we need here, that you need to practice for your exam 3, is finding the inverse of a function. Okay. So let me take that. Okay. Let me choose number 53. So we have 53. F of x equals to 2x over x minus 1, and we are asked to find the inverse of this function. So we have 3 or 4 steps, okay, when we are finding the inverse. What is the first step of finding the inverse of a function? We write down, okay, we replace our f of x by y. Okay, so this is our f of x. Okay, so we replace this f of x by y. That is the very first step. So we have y equals to 2x over x minus 1. So every time if you are asked to find the inverse of a function, you replace your f of x, or you might have a g of x, and the process is same. Okay, you replace g of x by y. You might have h of x, you replace h of x by y. Okay, and this is the first step. Second step is we interchange x and y. So for y, we write down x. For x, we write down y. So for every y, we write down x. So for this y, we write down x equals. Now for every x, we write down y. So we have 2y divided y minus 1. So you interchange x and y. The next step is we solve the equation for y. We have to solve the equation for y. Solving means we have to have y by itself in one side. Okay, now we are trying to solve y. We do have a denominator here. So y is in the denominator. So we have to get rid of this. How do we get rid of this y minus 1 from the denominator? how do we get rid of y minus 1 from the denominator? Multiply by what? By the same denominator. So we multiply both sides by y minus 1. So y minus 1, y minus 1. So this cancel and there is no more denominator. So on the left side we can distribute x. So x times y, x times negative 1. So we have x, y. So we have x, y, x times negative 1, that is negative x equals to 2y. We are solving for y, okay, keep that in mind. So now let's collect the term with the y in one side, okay. So we have x, y and 2y. These both have the y in it. So we collect these two terms together. So let's get rid of x, y from left side. So for that, we subtract x, y on both side. So this cancel, which is 0. So we have negative x equals to 2y minus xy. We are solving for y, okay. So we are trying to make y by itself. So we collect the y terms together. Now on the right side, what can we do? So in these two terms, what do you see as a common? So what is common? Y is common, right? So let's factor out y. So we have a y as a common factor, and if you factor out y from 2y, we have 2, and if you factor out y from xy, we have negative x, okay. Now the very last step here, we are almost done. Now we need to get rid of this 2 minus x from y. How do we get rid of this 2 minus x from y? Okay, yes, and the reason is that in between this expression and y, we have a product here. So we divide both sides by 2 minus x. So you divide both sides by 2 minus x. So this 2 minus x cancel. So our y, so we have negative x over 2 minus x equals to y. Okay, now our y is f inverse x function. Okay, so f inverse x is negative x over 2 minus x. So this is the inverse function. You will have a problem where you will be asked to find the inverse, okay. So the very first step is that you replace, okay, you replace your x by f of x by y. That's the very first step, okay. So the very first step is that you replace your f of x by y, okay. Second step, you interchange x and y, okay. So for y, you're gonna write down x. For x, you're gonna write down y. Then the next, you solve the equation for y, and at the end you replace your y by f inverse x, and you get the inverse function, okay. So I think, yeah, we almost finished the review. Make sure you practice the problems that we did in a class, okay. Or you can just, if you need extra, you can go back to the review and just practice more. Okay, let's do this much.